Hey folks, how's everyone doing? So today we are going to take a little bit of time to talk about how you can build modern streaming data analytics architectures on AWS using AWS streaming services such as the Kinesis family and Amazon managed streaming services for Apache Kafka. My name is Taz, and let's get into this. So streaming analytics is essentially the processing and analyzing of data records continuously rather than in batches. I mean, that's pretty much what it is in its simplest form. It is also known as event stream processing, which is the analysis of current and in-motion data. Now, generally, streaming analytics is useful for the types of data sources that send data in small sizes in a continuous flow as the data is generated. A typical life cycle involves ingesting streaming data for various data sources such as IoT devices, sensors, log events, incident triggers, and so on. There is usually an optional short-term or long-term storage requirement depending on your needs, such as playback processing, windowing. There is a stream processing phase that typically involves some transformation followed by delivery to a data processing endpoint, such as maybe a visualization dashboard or a real-time search engine. So the first service that we're going to take a look at is the Amazon Kinesis Data Streams, a serverless service to process and analyze streaming data with about less than 70 millisecond average latency. It supports built-in integrations with many AWS services such as AWS Lambda, Amazon EMR for building streaming pipelines. It has a 24-hour to a 365-day retention capacity for playback requirements, and shards are the way to define capacity in Kinesis Data Streams. So with shards, along with the provision mode for shards, we recently added an on-demand mode that automatically scales the capacity in response to varying data traffic. And as Kinesis Stream supports multiple AWS integrations, one of the brother integration is the Kinesis Data Firehose. Now, this is an ETL service that captures, transforms, and delivers streaming data to data lakes. AWS services such as S3, Redshift, and data stores such as Splunk, Datadog, Sumo Logic, New Relic. Amazon Kinesis Data Firehose now also supports dynamic partitioning, where it continuously groups in-transit data using dynamically or statically defined data keys and delivers the data to individual Amazon S3 prefixes by key. This reduces time to insight by minutes. It also reduces costs and overall simplifies the architecture. For working with streaming data using Apache Flink, we also have the Amazon Kinesis Data Analytics service. As with Amazon Kinesis Data Streams and Kinesis Data Firehose, this service is also a fully managed serverless Apache Flink environment to perform stateful processing with sub-second latencies. It integrates with several AWS services, supports custom connectors, and has a notebook interface called KDA Studio, Kinesis Data Analytics Studio, a managed Apache Zeppelin notebook to allow you to interactively work with streaming data. Similar to Kinesis Data Analytics for Apache Flink, Amazon Managed Streaming for Apache Kafka, or MSK, is a fully managed service for running highly available, event-driven Apache Kafka applications. Amazon MSK operates, maintains, and scales Apache Kafka clusters, provides enterprise-grade security features, and supports Kafka Connect, and also has multiple built-in AWS integrations. Now, let's review a few common streaming architecture patterns enabled by Amazon Kinesis and Amazon MSK. A most common pattern that we see is access log streaming applications that usually used for anomaly detection using Amazon Kinesis Data Analytics and Amazon OpenSearch service. So what you see here is essentially logs from multiple sources such as Amazon CloudFront access logs or VPC flow logs, API logs are pushed into the data lake. And then you publish S3 put events to Amazon SQS. Then you have our AWS Lambda pulling those events from SQS and invoking a function to move data into multiple sources such as Amazon S3, Amazon Redshift, Amazon OpenSearch, or even Kinesis Data Analytics services or Kinesis Data Firehose. With this architecture, you can build low latency modern data streaming applications by creating a near real-time OpenSearch dashboard and then processing streaming analytics with AWS Lambda and Amazon SNS for automatic notifications. You can also store access log data into Amazon S3 for archival and load sub-access log summary into Amazon Redshift, depending on your use case. Another architecture pattern or use case is around real-time reporting, where you derive insights from input data coming from diverse source systems for generating near real-time dashboards. So with this architecture, what you're seeing here is you can stream near real-time data from source systems such as social media applications using Amazon MSK, Lambda, and Kinesis Data Firehose into Amazon S3. You can then use AWS Glue for data processing and load transform data into Amazon Redshift using an AWS Glue development endpoint, such as an Amazon SageMaker notebook instances. Once data is in Amazon Redshift, you can create a customer-centric business report using Amazon QuickSight. Similar to the previous one, here's another use case for near real-time search, where you can derive insights from Amazon DynamoDB by setting up near real-time search using Amazon OpenSearch service. So in this design, the DynamoDB table is used as the primary data store, and Amazon OpenSearch service cluster is used to serve all types of searches by indexing the table. Using DynamoDB streams with Kinesis Data Streams, any update, deletion, or new item on the main table is captured and processed using AWS Lambda. Lambda makes appropriate calls to OpenSearch service for indexing the data in near real time. You can also use streaming functionality to send the changes to OpenSearch service or Amazon Redshift via a Kinesis Data Firehose delivery system. Before you load data into OpenSearch service or Amazon Redshift, you might need to perform transforms on the data. You can use AWS Lambda functions to perform this task. Another use case is around monitoring streaming data with machine learning to identify and act on deviations from forecasts in near real time. So with this architecture pattern, this is how the flow looks like. Data is collected from multiple sources using Kinesis Data Streams. It is then persisted in Amazon S3 by Kinesis Data Firehose. Initial data preparation and aggregation is done using Amazon Athena and then stored in Amazon S3. Amazon SageMaker is used to train a forecasting model to create behavioral predictions. As new data arrives, it is aggregated and prepared in near real time by Kinesis Data Analytics. The results are compared to the previously generated forecast. Amazon CloudWatch is used to store the forecast and actual values as metrics. And then when actual values deviate, a CloudWatch alarm triggers an incident in AWS Systems Manager Incident Manager. So these were a few architecture patterns for streaming services, streaming applications. Let's look at a few key considerations when working with streaming services, AWS streaming services and streaming applications, when you need to choose a particular streaming service or building a solution. So usage patterns. Um, Kinesis Data Streams is for collecting and storing data. Kinesis Data Firehose is primarily for loading and transforming data streams into AWS data stores and several SaaS endpoints. And Kinesis Data Analytics is essentially to analyze streaming data. Next, we look at throughput. Kinesis Stream scales with shards and supports up to 1 megabyte payloads. As mentioned earlier, you have a provision mode and an on-demand mode for scaling shard capacity. Kinesis Firehose automatically scales to match the throughput of your data. The maximum streaming throughput a single Kinesis Data Analytics for SQL application can process is approximately 100 megabytes per second. Next, you consider latency. So, for example, Kinesis Streams allows data delivery from producers to consumers in less than 70 milliseconds. And then finally, ease of use and cost. All the streaming services on AWS are managed and serverless, including Amazon MSK serverless. This allows for ease of use by abstracting away the infrastructure management overhead. And of course, consider the pricing model of each service for your unique use case. So with that, we now have a few additional resources for users to dive deeper into these services and the architecture patterns. There's workshops available for folks looking to get a hands-on experience. There's blogs that provide prescriptive guidance on building streaming applications and working with streaming data. So with that, thank you for your time. Appreciate it.